Well, this is lesson 59. Apparently I forgot to do videos this week. I always forget if I taught all 4 lessons or not, and this week I really forgot. So this lesson is quite a complicated lesson, so it's really important that you watch this even if you tried to do your homework. This lesson has 3 parts: experimental data, simultaneous equations with fractions and decimals, and rectangular to polar form. Now the first kind of problem everyone really hates, and I'm hoping that after I do this that you're going to think, oh, that's not bad. So let's look at that one. Example 1. The data graph below, or data, came from an experiment involving bronze and copper. The shading around the points indicates that due to potential errors in measurement, the data may not be exact. The line represented by the data points has been estimated. Write an equation of the line which gives bronze as a function of copper. Notice that the 2 scales are different. So what happened is they did an experiment where they found that if there was approximately, let's say about 7 kilograms of copper, that there were maybe 8 kilograms of bronze. So they plotted the points in several different experiments, in one experiment, and then they wanted to find a line that appropriated the data. So someone came up, in your book the lines are drawn for right now. Maybe later on in the book they don't draw the lines and you have to approximate your own line. So they drew a line that's approximately, like if you kept going, if you had 20 kilograms of copper, you might have, up here into the 70s of bronze. But we can make an equation that can actually tell us. We could put 20 in and see how much bronze it would be, because it would be close to this line. So what our job is to write an equation of a line for this line. Now to write an equation of a line, we need 2 things. We need a point. So our point would be, we need a point x1, y1, and we also need a slope. Those are the 2 things that we need to find in order to write an equation of a line. This is the standard form. This is our slope-intercept form of a line. So we have a y, would be the y-axis, and our x is our x-axis. But since we're dealing with bronze instead of y-axis and copper instead of our x-axis, we're going to rewrite the equation. We're going to replace our y with b for bronze, and replace our x with Cu, because that's the symbol for copper. So all we need to do is find a slope and a point, and we're going to plug it in this formula and rewrite it with b for the y and Cu for the x. So let's get going. The book makes it easy on you. I don't think they're all going to be this easy, but this example is easy. You pick points. You look at the line and you pick points that are right on the grid line. So you can see that this is a point right on the grid line, right there. It's where they cross. And right here, this point is right on the grid line. It's where they cross, where it crosses the grid line, so that we can get a good count of the rise over run. So first thing we're going to do is we're going to come up with our slope. Our slope is simply rise over run. So it's how far we rose to this point and then how far we ran to this point. And if you count how much we rose, it starts on 5, and if we keep counting, we're going to get up to here, we get 35. So you're going to form a right triangle between the 2 points that you pick on the grid line. This is going to be a right triangle, like that. And then we can pick out our rise. So our slope is rise is 35 over run. Here's our run. If we're going to rise 35, then we run, and make sure you use the scale on the bottom. We're going to run 10. We're going from 5 to 15. So our slope is 35 over 10, or we can say our slope is 3.5. Then you need to pick a point. The point that we can either use this point right here, 5, 5. That seems like an easy enough point to pick. But I'm going to stick with the one that they used in the book. They used the point, they used the point 15 and 40. So let's see where that ends up. 15 and 40. So that's an actual point on the line, so I guess that's a better choice. So for our point, we're going to use the point 15 and the point 40, or the coordinate 40. So that describes this point. So we came up with our slope, our rise over run, and we picked one of the points. And now we're going to take our equation, this is our slope point equation, and we're just going to fill in the information. So we get y minus y1, which would be our y coordinate, so that'd be 40, equals our slope, which is 3.5, times x minus 15. So bear with me because I'm doing it different than the book does, so I'm going to need to use my calculator. Alright, so we're going to get y minus 40 equals 3.5x minus 15 times 3.5, which is 52.5. And then all I need to do is add 40 to both sides, so we get y equals 3.5x minus 12.5. Finally, we're going to put in our correct letters. So we're going to say B equals 3.5 Cu for copper minus 12.5. Now the benefit of this looks like a 13, doesn't it? The benefit of this is we can find, if we had 20 kilograms of copper, we can find out how many kilograms of bronze that we would need. You would just fill in 20 here and do your problem, and you'd find out how many kilograms of bronze. So hopefully that all made sense. A lot of times people have trouble with these, but I think it seems pretty clear. So let's try this. This lesson has 3 totally unrelated lessons to it. So let's move on to the next one. Here we go. This one is simultaneous equations with fractions and decimals, our favorites. The good thing about equations is that you can eliminate your fractions and decimals and you really don't have to deal with them. You can only do it if there's an equal sign. Don't try to get rid of your fractions or decimals if there's no equal sign. First thing we want to do is get rid of our fractions and decimals. So we are going to multiply this equation by the common denominator, which is 10. And we're going to multiply this equation. We're going to move the decimal point over 2 places, so that's the same as multiplying by 100. So if we do that, 2 goes into 10 5 times, so we get 5x. 5 goes into 10 2 times. 2 times 3x is 6y. 5 goes into 10 2 times. 2 times negative 2 is negative 4. So we eliminated that one. That wasn't bad. And now we're just going to move our decimal points over 2 places. That's the same as multiplying by 100. So we get 6x minus 20y equals 104. Okay, it's still not the best equation in the world, but we're going to work with it. At least we don't have fractions and decimals. Okay, so what we need to do is multiply the top equation by something, the bottom equation by something, and hope that something adds out. So the extra credit problem will be, can you hear my washer in the background? It's extremely noisy. So I'm going to multiply this one by negative 6, and I'm going to multiply the second equation by 5, and you can see here that we will eliminate the x's. So here we go. Negative 30x minus 36y equals 24. Take 5 times the 6x, we get 30x minus 100y equals 544. 520, sorry. Now we can add these up. These would add out. This is going to give us negative 136y equals 544. Divide both sides by negative 136y, and believe it or not, by negative 136, believe it or not, y equals just a simple little negative 4. problem's not done until you go get your x. So I'm going to replace it into this equation right here. So we're going to get 5 times -4. Actually it's y, so I'm not going to put it there. That would be silly. 5x plus 6 times -4 equals -4. 5x, I'm going to add -24 to both sides, equals 20, and x very nicely is 4. So the ordered pair that makes this equation true is x is 4, y is -4. Alright, finally, one more part in this lesson. Alright, here we go. This is a new concept, so don't tune out yet. Okay, we're supposed to convert -5r minus 3u to polar form. First thing you're going to do is plot this point right here. So this is -5 right, so I'm going to march over here, -5 right, and -3 up, which means down here. So first thing you do is you're going to plot that point on your graph. In order to write it in polar form, we need the magnitude, which is the length of the hypotenuse, and the direction, which is this angle. So what we're going to do is make some sides. We're going to make ourselves a little triangle so that we can figure this out. My noisy dryer, okay, washer, it's finally done. So I'm going to make a triangle here, and I can figure out the sides of my triangle. This side right here is 3, and this side right here is 5. So if we want to find the angle, we know that the angle is equal to, we could either use sine as opposite over hypotenuse, but we don't know, we need to know both sides in order to use the inverse tangent, or the inverse sine. I'm giving it away now. So we can't do opposite over hypotenuse because we don't know the hypotenuse, and we can't use adjacent over hypotenuse because, again, we don't know the hypotenuse. So the only one that we can use is we can say the tangent of theta is opposite over adjacent. Now keep in mind, when we want to find the angle, we're always going to use on our calculator the inverse tangent. So we would say the angle equals the inverse tangent of 3 divided by 5. When you want to do the angle, it's always the inverse. So we just get our calculator out and we put that in, so it's going to be that theta is going to equal the inverse tangent of 0.6. And I'm going to put that in my calculator to make sure that it comes out. So I'm going to do tangent 0.6 inverse tangent, and I get 30.96, so we're going to round that off to 30 degrees. So our theta is going to equal 31 degrees. So again, polar form, we need an angle, which we just got, 31 degrees. And we also need to know the length of this hypotenuse. Now at this point, you could do the sine and cosine. You could do, I'm just saying you could do it, but I wouldn't choose to do this method. You could just say something like sine of 31 degrees equals opposite over hypotenuse, and then you could solve for h. Or you could say the cosine of 31 degrees is adjacent over hypotenuse and solve for hypotenuse. Or, I think the easiest thing to do in this case, it's a right triangle, and anyway, this angle is wrong down here, so I'm going to have to fix that in a minute. You use the Pythagorean theorem and you can easily get the hypotenuse. So we would just say 3 squared plus 5 squared equals h squared. We would get h equals or we can just say h squared equals 34, and the length of the hypotenuse is the square root of 34. Now if you would have done it this method, you would have got something close to this, but this is the most accurate number, because here we ended up rounding. Now so we would put right here square root of 34. Now anyone see why 31 degrees is incorrect for this? Think about it. I'm just going to erase that because it's so wrong, and I'm going to show you what's wrong with it. This right here is 31 degrees, but when we figure out the direction, we have to start at the x-axis and go the whole way to the line. So it's really 180 plus 31 degrees. So our angle is really 211 degrees. So from going from rectangular to polar form, the first thing you have to do is you're going to be using the tangent every time. So you're going to use the tangent of the angle is opposite over hypotenuse. Then to find the actual angle, you take the inverse of the ratio, and that gives you the angle. Then you can use the Pythagorean theorem. Just make sure when you do your actual angle, you have to start at this point and go the whole way around. Even if it's over here in the fourth quadrant, you need to go the whole way around and figure out what the angle is. And that's your direction. This is your magnitude. That was a rather long lesson. I hope you guys watched it.